Welcome back to Tad Talk Sustainability, where every week I sit down with my dad and sustainability expert Tad Radzinski to ask him questions about sustainability topics. This week we are going to be talking about life cycle assessments. And as usual, we'll start it off with the basics. What is a life cycle assessment?
So, a life cycle assessment is a study of a product or a service from cradle to grave. And unfortunately, we have to say cradle to grave because our whole society is based on us making something, using it, and then disposing of it. However, that is, just the way we approach this from a life cycle perspective. And really, what we're looking at is very beginning life of a product starts out with raw materials. So if you think about it, I like to give an example. If we think about paper, okay, so the paper we write on or we print something out is not, magically paper. It starts out as a tree in a forest. And in the raw materials extraction stage, what happens is a logger is going to come in, they're going to cut down the trees. The trees are then going to be transported by what we call like a log kids skid steer or something like that. Then it gets loaded onto a log truck and transported to a facility that will then process the log. And when they're processing the log, they'll remove the bark and then they'll start to take the tree and grind it up and start to make it into pulp. And eventually they go through a whole process of making paper. So all those steps I just explained, the logger coming in with the chainsaw to cut down the tree, there's energy, there's fuel used to do that. There's fuel in the equipment that basically drags the tree out of the forest and puts it on the log truck transports it. And then at the facility where they're going to remove the bark and do everything they do to make it into pulp, there's a lot of inputs of energy and emissions that come out of that. So what we're looking at then is that life cycle stage would be the raw materials extraction and the initial product manufacturing. The final product manufacturing would be where that pulp is converted into the paper. The paper is then packaged up and shipped to your local Staples or wherever you buy your paper. And then we eventually buy it, we use it, and then at the end of use or end of life, that paper will either go into the landfill or get recycled or, go off to waste to energy. So you can see that's the cradle to grave, right? We started with the raw materials and then we rotated all the way around. But every step in that process, we need to understand what were the environmental impacts of that, making that paper. Now, ideally, what we would want to be looking at is a circular system where we go, instead of taking that paper and landfilling it, we'd want to recover it and then send it back to a mill where they can repulp it and make it back into paper. That would be an example of going to a closed loop process or a circular economy type of process where we would recover that material. So it is really complicated because there's a lot of steps that you have to evaluate. And I just picked something simple with paper, but imagine if we're doing something with much more complicated materials that involve a lot of chemicals, like this, we're doing this recording right now on this microphone or with this laptop. You can do a life cycle assessment of those also. And then you got to think about everything that goes in there, the petroleum to make the plastics, the chemicals, the circuit boards, the screen, the glass, every little material you have to look at and understand how it was made and then eventually assembled into the final product.
Wow, that sounds like a lot. Sounds like a very complicated process trying to understand all of those impacts from the raw materials to the final product. How do people do that?
So typically what they're going to do is there are life cycle assessment softwares. There's a couple of them that are used. In our company, we use one called SimaPro or another one called Gabby. And those softwares actually have a lot of that data already built into them. We call those data sets or processes. So in that paper example I gave, if you wanted to understand what it took to get the logs out of the woods and off to the manufacturing site, you could go into your software and you would look in either the US LCI database or the EcoInvent database or there's a lot of other ones in there. And you would say, I'm looking for paper making or pulp production. And you would go in and you would find that information. You could then read all about it and see what steps it covers. And then you grab that and you pull that into your life cycle assessment model. And then you can just keep doing that. And that, what I just described to you, is information that we would call secondary data, because it's coming from an existing database of information. It's not going to be very specific. Like, it might be information from Europe or US in terms of the actual production from some other work someone did from a life cycle assessment. But if you wanted to know, okay, I'm harvesting the trees in Pennsylvania and they're transported to Ohio, you may not be able to find the exact impacts of harvesting in Pennsylvania. However, the transportation piece is something that you would then run an analysis on by calculating the distance and the mode of transportation. Is it truck? Is it rail? And then inside the software, you can build all the different stages and all the different steps to get the outputs. And once you do all that, now let me circle back. Typically, when we're doing this, if we're going to do a life cycle assessment, it's usually a manufacturer of something that wants to do the life cycle assessment. So we've done a lot of different building products. We've done food. We're actually working on some automotive products right now and parts. And if you start looking at it, it's usually the manufacturer of the product that wants to know, what are my life cycle impacts? Because they're getting questions from their bigger customers. Like in the world of automotive, the big manufacturers might be going down to their suppliers saying, we're doing a life cycle assessment on a whole vehicle. We want to know what your parts contribute to this. Or in a building product situation, it could be someone who's making gypsum wallboard or fiberglass insulation or flooring or carpeting. And the architects and designers are asking them for this information because it's required for green building standards and certain laws right now. So if it is the manufacturer that's doing it, then they're going to be able to give us a lot of information. We get what we call primary data on their manufacturing. So they would tell us, all right, we use all these different raw materials. We'd be looking at what we call the bill of materials of everything that goes into making the product. We would then understand their manufacturing process. And a lot of our team here that do life cycle assessments are chemical engineers, because they really understand how a process works, in terms of manufacturing and things like that. So our team would typically get the bill of material. They would collect a whole bunch of data from the manufacturing facility to understand all the energy, water, waste, emissions, raw materials, packaging, everything about it. And then they would put that into a data sheet and they would create what we call the life cycle inventory. That would then be rolled up into then going into the software and building out that model using the inventory. We always also understand who their suppliers are, or where the suppliers are located, because in that beginning stages of the LCA, the raw material stage, we're going to look at where the supplier is, and then we have to calculate how far did they have to ship it, how did it get here. And if you're getting a lot of materials from China, there's a lot of impacts for shipping, right? And also the manufacturing activity in China is driven by the electricity grid there. So if China burns a lot of coal, then that dirtier electricity is going to contribute to higher impacts when you actually run the calculations. So you have to know all that information. And then once we have all the data, that again, we're going to have the primary and secondary data. We run the analysis and we're going to get results. And the results are typically going to be in the form of different impacts that occur at each life cycle stage. So if you want to know raw material stage, you would build your model so you can actually get an output to tell you what were the impacts of each ingredient and the shipping of it and everything else. Same thing with manufacturing, and then from manufacturing distribution out to the market. So if it goes from manufacturing to a distribution center, or from distribution center to a retail store, those steps would be included. And then if there's a installation phase where you have to install the product, we would calculate that information. If there's a use phase and it uses energy in the use phase, we would calculate that information as well. And then at the end of life, we want to know what happens at end of life or end of use. Is it typically disposed of in a landfill? Is it recovered and recycled and reused? Does it go to waste to energy? What happens to it? So all of those steps are then modeled in the LCA software. And then the outputs will be different impact categories. For example, global warming potential is going to be all the greenhouse gases that are generated throughout the life cycle. And when we talk about embodied carbon of a product, we're typically talking about the very beginning stages, the raw material stage, transportation of raw materials to manufacturing, and then possibly transportation out and installation. Those would all be covered. And that's where we get the term embodied carbon. And that would be all the global warming potential greenhouse gases that were generated in all those stages from the energy used in every step in the process, even including, and we have to think about this if we're talking about something that's a plastic, we have to go all the way back to the oil well or the natural gas well to understand that impact. And that's what the beauty of the software is, do that automatically, because it would be very, very difficult to collect all this information and run a good LCA if you didn't have the software. Another impact category that we'll look at is fossil fuel use, what we call embodied energy. Okay, that's just the total energy that went into making the product. And that includes not only the energy from utilities like electricity and steam, but also the fuels that are used. But sometimes there's a thing that's called feedstock energy, and that would be fossil fuels that actually go into making the product. So in some products like vinyl flooring, for example, they use natural gas as part of a feedstock energy that is then converted into ethylene that then is used to make the vinyl chloride monomer that eventually makes the vinyl flooring. So there's a lot of things you have to know. It's very detailed. And other impact categories might be acidification. That's where when we burn certain fuels like coal, for example, you can release things like sulfur dioxide into the atmosphere that creates acid rain. Okay. Or because we combust, we talked a lot about combustion and the impacts of making electricity. Anytime we burn something, we're also releasing a thing called nitrogen oxides. And that nitrogen oxides, because nitrogen is 79% of the air that we use in the combustion process, that goes up in the atmosphere too, and also creates acid rain. So there's a lot of other impact categories, but there's some ones that people might have heard about and understand. Ozone creation and ozone depletion are two other ones that we look at, like ground level ozone. So all those things are calculated in the software.
Wow, that is a lot. And definitely very, very important to consider all of those things when you're trying to figure out the impact of your products. So once an organization understands this information, what can they do with it?
Yeah, a lot of companies that ask us to do this work are trying to meet a requirement. So if the United States Green Building Council has credits in the LEED standard, Leadership in Energy and Environmental Design standard for green buildings, there's points you can earn by selecting products that have these things called environmental product declarations. So what we'll do is most companies want us to run a life cycle assessment so they can do the environmental product declaration and get that published. And that's a much more simplified document that doesn't disclose all the company's top secret stuff like we just talked about, their bill of materials and their recipes and all that, or their manufacturing processes. But it gives enough information that you could understand the impacts of the product. And then the architects, designers, and other folks that are doing the buildings can look at that information and try to select products with lower impacts compared to other products. Okay, that's a big movement right now in the green building world. And actually, many architects and designers are really committing to selecting products with reduced embodied carbon or reduced global warming potential in their life cycle. And that's one form that they can do with it. However, I don't recommend that companies just do that. They can definitely make an EPD to meet a LEED credit, but I strongly recommend that they take that information, they understand all the impacts across their life cycle, and then they use that to do what we call sustainable product innovation, where they're going to go into their new product development process. Anytime somebody makes a product, there's a whole planning process. They use this process called the stage gate process, where they come up with an idea and then they say, we're going to make a new product or we're going to make a new generation of an existing product. And they go through this whole process to figure out how they're going to do it. And if they use that life cycle data as part of that, they would know where the impacts are. What are the biggest impacts from the raw materials stage? What are the biggest impacts in manufacturing? What are the biggest impacts in transportation and sourcing? And then they can make decisions in the new product development stage to look for alternatives or try to go with different materials or to source from a different supplier, anything to reduce that impact. Or if it's a product that uses energy and they understand that the energy or use phase is driving the overall environmental impact of the product, they can definitely use that to figure out how to make the product more energy efficient. So that's another thing that can be done. And then there are regulations coming out. In California right now, they actually require certain building product manufacturers to produce these environmental product declarations. And what California is doing is they're setting a level of the amount of embodied carbon they will allow for certain products like flat glass, structural steel, mineral wool insulation, etc. And they are creating laws around that. So number one, it's forcing the manufacturers to disclose the information. And then if a manufacturer has a global warming potential or embodied carbon number above the limit, they won't get selected for use in any kind of activity in construction projects within that California is basically funding, like for, state buildings or roadways or things like that. So we're seeing a lot of that. Even concrete's another big one where they're setting these limits. And a lot of the architects and designers are now looking at this tool called the Embodied Carbon Calculator that was put together by buildingtransparency.org and a group of different building product manufacturers and other folks. And it allows you to take all these environmental product declarations and start to compare the embodied carbon among different products by brand. So it's heavy pressure for any building product manufacturer. Number one, if you don't have the EPD and everybody's looking for that information, you won't be able to sell your product. But if you find out that your embodied carbon or your global warming potential for the very beginning stages of your product are higher than your competitors, then you have to figure out what are we going to do, because there will be architects, designers, building owners, and governments that are going to start selecting products based on that number in there. So it's a really big deal, and it's exciting. In some cases, it's probably nerve-wracking for a lot of the manufacturers because they got to now figure all this out. But there is definitely steps they can do, like I just explained. Understand it, do the life cycle assessment, and then integrate it into your new product development process through sustainable product innovation.
Yeah, absolutely. And I think an important thing to remember about everything we just discussed is that there are experts out there that can help you do these life cycle assessments. This isn't something that you just Google one time and figure out how to do it on your own. It's really important, if you want to get the best quality LCA, to hire someone to do it for you that will actually do a very good job and make sure it's the best possible LCA that you can get. So thank you so much, Tad. This was a great episode. Very scientific information that was discussed today. So thank you again, and we will see you all on our next episode.